Okay. All right. So thanks everybody for joining us today. Today's session is about securing your Jupyter Notebook sessions when running on Expanse at SDSC. So my name is Marty Candice. I work in the HPC User Services group. So this is the group that sort of is on the back end. If you ever email us about a problem with the help at exceed.org or through the ticketing system on the Expanse or the Exceed user portal. So maybe I've talked to some of you before, maybe I haven't, but glad you could join us today. Okay, so let's get started. So hopefully you know what today's session is about. You want to run Jupyter Notebooks on Expanse. And so if you're not interested in doing that, you probably signed up for the wrong class today, but that's okay. You can stick around and learn about what we're doing here. And in particular, I want to introduce you to some of the new tools that we have on Expanse and sort of have been around now for about a year of trying to provide you with an easier way to launch your notebooks more securely on SDSC systems. And so I'll talk about, my main goal today is to get you familiar with this Galileo tool by the end of the session, if you haven't already used it. This is the way we now recommend that you run your notebooks on Expanse, and it's also available on other SDSC systems. But yeah, and so at the end of the day, we want to get you from the command line to your notebook, working with your data sets, with your analysis, with your code, and so you don't have to worry about sort of these issues with security. We'll talk about a bit today. Now, the reason for this, trying to build these tools and facilitate your interaction with Jupyter Notebooks is there are some ways that you can run these notebook servers on remote systems that can be less secure than other ways and can lead to issues. And so, just a quick review, of why does security matter for you is, even though you may think that you are not a target of malicious actors out there on the internet. They're just everywhere and they don't care. They're just looking for data and things that they can take and maybe monetize at some point or use the resources that you have access to for other things, right? So you really do want to protect your research software and data, whether it's open source, proprietary, it could be export controlled. You don't want to lose access. You don't want to lose that, right? Especially if you're a PhD student working on your dissertation and you lose all your data from the last 3 years, that's not it's not a good day. So you really do want to keep in mind using systems like SDSC's Expanse, securely for your research, right? And so these are just some of the other reasons that people will try to access your accounts and get a hold of the resources you have access to, whether it's using the network that's available to SDSC to either attack other systems within like the UCSD network or external attacks. Also, obviously, using the compute resources you have access to for things like crypto mining, is kind of a big thing these days, right? That we see. So, just keep in mind, there is good reasons for doing things correctly and safely, and to keep your data and research away from bad actors. And they're out there. They're even though you think you may not being attacked, like for example, probably in the last 24 hours, Expanse received millions of attempts to log in with different usernames and passwords. And in particular for today's talk, right? Probably thousands of connections. Attempting to find Jupyter Notebooks and get into the system that way, right? And so this is why you want to be vigilant when you're using Jupyter Notebooks on any system that you're running, right? And sometimes the bad guys get in, right? So this was a recent attack that was on not Expanse, but I think another SDSC system, and this was sort of a sequence of events. So the attacker found a Jupyter Notebook server running with like either no password or a weak password set by the user, and that notebook was cracked essentially, right? And so if you are someone who runs your Jupyter Notebooks and sets a password so you can log in, log out, as it's sort of sitting there running maybe for a couple days. We would recommend you don't do that and simply start up a notebook server with the full sort of tokenized URL that you get, and use it until you're done, shut it down, and then start up a new notebook rather than leaving it running, right? So this is kind of one way that people get in quite commonly, right? So in this case, the attacker used the notebook server that they got into to then you have access to the full file system in the user's home directory or whatever file system they may have, and so they had some SSH keys that had no passphrase. If you use SSH keys, please use a passphrase. And then so they stole these keys, installed some crypto mining software, and then the user reported they found some weird software in their account, and sort of how this was discovered, right? And so while this was one of these instances where, oh, okay, they're just like stealing compute resources to mine some sort of cryptocurrency, it could have been a lot worse, right? Not only could the user have data been stolen and held for ransom if it was really important, right? Again, if someone gets in and is poking around the system, they may find other people, other researchers' data and software on the system. And so not only could it affect you personally, but it could affect other people on the system if for whatever reason their home directory is readable by a bunch of people and they can get in somewhere over there and steal some data. It's not only your account that can get compromised by getting in through your account, other people's can be compromised as well in their data. So as we talk about, as I kind of warn you about data, one thing to definitely keep in mind is, in general, regardless of running Jupyter notebooks or not, please back up your data. Right, on Expanse, we only have backups, sort of semi-regular backups of your home directory, which is only 100 gigabytes, right? So that's the only backup of any data that's stored on Expanse at SDSC, right? For example, a lot of people keep most of their data in the Expanse Lustre file system, right? But we only have a single copy of that data there, regardless if it's the Scratch storage or the project storage, right? We can't. NSF doesn't fund these systems to the level where you can have a backup system for a 12 petabyte storage system, right? So there's only one copy of the data there. So if you have very important data that's backed up on the Expanse, or is stored on the Expanse Lustre file system, please make regular backups of any important data that you want to keep around long term to your own storage at your home institution or your personal file system at home. This is right. If the data gets compromised in some way, on the system, it's gone basically, right? So please back up your data. Also, just to note on Expanse, if you're new to Expanse, right, we have some new policies on the Expanse Lustre file system. We do have purge policies now. This was not the case on, say, Comet. If you were a Comet user in the previous years, right? We have a 90-day purge policy on the Expanse Lustre Scratch system. And so that means any file created, after 90 days, 90 days after the file was created, it will be deleted, regardless if it's still in use. So please, use the Scratch file system as a Scratch file system. You should not store data there long-term. If you want to store it there long-term for like the duration of your allocation, please move any important data from Scratch once it's used and computed and analyzed. Move it back to your project storage, right? That project storage will stay around until 90 days after your allocation expires, right? Because we are starting to get emails where people are leaving their data in Scratch and saying, where did it go? And then we point to the user guide and say, well, don't leave your data there, right? It really is a Scratch file system, temporary storage while you're doing, active runs and whatnot, right? So if you need more long-term storage, please apply for more allocation in the project storage space. Okay, so now that we sort of talked about the background of some security aspects and sort of how to manage your data and keep it safe on our systems, let's talk about sort of the general ecosystem that you might have in mind, or at least I have in mind for you when we were talking about Jupyter notebooks, right? So, right, either you're working on your home desktop or laptop, maybe you have a lab workstation server that you're doing your research on, and then you have access to an HPC system like Expanse, right, where we have a bunch of different types of compute resources and what they're supposed to be used for, right? And so just to familiarize you with what those components are sort of at the highest level, if you're sort of new to an HPC system, right? There are sort of where you log into the system, we call those login nodes, right? We have them, that's just where you will log in, access the scheduler, submit your jobs, maybe compile some code, edit some text files, input files, very lightweight work. You should not be running any sort of computational work there, even if it's just sort of to debug your code, right? We have actual debug nodes in the bank of compute nodes as well that you should use for that kind of stuff, right? So login nodes will, you'll launch your jobs to give you access to the compute nodes on the system. That's where your actual computational workloads should run, including in this case your Jupyter notebooks. This is all managed by some management nodes that run sort of the system software, the scheduler, file systems and other things. And then there's, the network file systems, like your home directory is an NSF file system, NFS file system. And then the Expanse Lustre file system is what you're also familiar with in terms of network file systems on Expanse, right? So that's kind of the landscape of the compute resources that I imagine that you're working on and how they connect to a system like Expanse. Okay. Now, when you're developing your notebook, I'm assuming you're probably doing most of it on your laptop or desktop at home, right? So you're running your Jupyter notebooks, what we would say locally, right? You're just running, for example, on my Mac. I can just type. I have Jupyter Lab installed with, Homebrew, and I just type Jupyter Lab. It gives me a URL. I paste that in my browser, and I can start working, right? So that's very simple, very straightforward. That's very safe to do. You can, run that all day long on your home laptop, right? And I do have in this talk a bunch of screenshots and things. I probably won't go into detail. It's just here for sort of reference if you're not familiar with starting Jupyter notebooks and what the output looks like. I have sort of these command line outputs from, say, running Jupyter Lab locally on my Mac here and getting the URL and pasting it into my browser to start my notebook, right? So there's a few screenshots here. We don't probably go into detail on most of them, but they're sort of here for just a reference of the sort of the workflow of each case that we're about to go through here. Right. The next sort of scenario that you're probably most familiar with is, so maybe you have a workstation server at the lab where you actually have more compute resources. Maybe you have a GPU server or something in your lab, and you want to run your notebook remotely there, right? And so what you usually would do in that case, or what you may be familiar with, is you SSH into that remote workstation server, and then you start up your Jupyter notebook or lab application, and you attach with it, a specific host name or IP address, and this, -- no browser command line option, right? And then what that allows you to do is then connect to that URL of, if there's a public URL for that, workstation or server, or just an IP address, and paste in the URL that Jupyter provides you that you're familiar with, and then you can connect to from your laptop or desktop at home to that Jupyter Lab or Jupyter Notebook server that's running on the workstation in the lab at your university, and you can work remotely in that case, right? The problem with this, even though this is very simple, sort of probably the next simplest, besides running locally on your home desktop or laptop, this is probably the next simplest way to run a Jupyter notebook, and you may have been doing it this way for some time. One of the fundamental problems with doing it this way is you leave exposed all of the traffic between the lab workstation server here and your home desktop, right? So all of the commands and data passed back and forth between your home desktop and the lab workstation is in plain text, right? So in theory, someone on the internet can see that traffic at some point, right? And so there could be someone in the middle who can monitor that traffic. And if you're somewhat familiar with running Jupyter notebooks, right, in these URLs, you have this random string token attached to the URL, which is sort of your unique one-time password, right? But sending passwords in clear text over the internet is not necessarily ideal, right? I'm sure people have been doing it with Jupyter notebooks for a very long time. So in theory, you could get intercepted, with that token, and someone can just they'll have access to your notebook right away, right? It's only so many times that token gets passed, right? It's like probably once or twice, but it is a risk. But I would keep in mind that all of the data that's being transferred between both endpoints here is in clear too. So if there's any sensitive information during that exchange, right, that's also open to being observed and or possibly even tampered with, right? So this is not the ideal way to do it. I know probably many of you, if you've been doing notebooks for a long time, have done this in the past. It's just not ideal, right? And so, yeah, so again, these screenshots here, I kind of did an example where I mimicked doing that kind of setup running from Jetstream, if you're familiar. It's the OpenStack cluster available through Exceed. So again, these screenshots just sort of walk through the same process of doing this insecurely. I shut it down pretty quickly, right? So hopefully it was fine, but it's just not what to do. And you can see here, right, in your web browsers, right, you're probably familiar with whether or not you go to a HTTP web address or an HTTPS address, right? Like most browsers now have this sort of symbol if the traffic is secured between your browser and the address that you're visiting. So you can see here, just in this case, it's not not secure. It's just plain text HTTP traffic. So if you've try to take a bit more caution, you may be familiar with this technique. Is you can basically do the same technique of running the notebook on your lab workstation remotely, but you can also wrap that traffic in an SSH tunnel, right? So this is probably the best solution for you manually. If you've been doing this last method here, if you want to up your game a little bit, the next best, security-wise, the next best option for you is to wrap that open HTTP traffic in an SSH tunnel, right? So if you're not familiar with this technique, I definitely recommend understanding it and learning how to do it. Whether you're using a Mac, a Linux machine, or even Windows, right? This is the same solution essentially for any type of system, right? You can do this approach where you actually then at least encrypt the traffic between your, say, lab workstation and your home desktop, right? So people can't sort of sniff out what your data is that's being exchanged between the two endpoints. And so this is also the most common way that we've in the past have taught users to run Jupyter notebooks on systems like Expanse, right? I'll come back to that in a second, right? So you can do the same technique using just SSH tunnels directly into compute nodes on Expanse. And so there's an example of screenshots here, that are available after if you want to look at how to do that. But if you've ever done this, it's a little bit cumbersome to set up. Sometimes it gets confusing. You forget how to do it. And so what we've been doing is trying to come up with a simpler way to help you protect your data and the traffic between your, your desktop, laptop at home and a system like Expanse, right? And so that's what we're really going to talk about the rest of the talk. I just want to go back. So when you do want to start running your Jupyter notebooks on Expanse or any system like that, please do not run your Jupyter notebooks on the login nodes. Our system administrators will likely lock you out of the system and until you say until you apologize. So, but this is a general rule for anything that's sort of computationally intensive, right? So the login nodes are really meant for very lightweight work, transferring data, maybe compiling code, editing your input files for your calculations. It's really not a place to run any service like a Jupyter notebook that could also run, very computationally intensive things, right? These are shared resources that many users are using simultaneously at the same time. It's not meant for computational work, right? Everything should really be run out on the compute nodes, including your Jupyter notebooks, right? Okay. So again, there's a few screenshots here. We don't really have to go. Maybe I'll walk through this one and, just to refresh your memory if you're not familiar with this SSH tunneling, right? Doing this on Expanse sort of looks like this, where you log into Expanse. You start an interactive session. So basically this is requesting a full node job on Expanse. And so then I'm allocated by the scheduler this Expanse 252 node. The job is now running. And so I can do anything that I would do normally, on sort of a command line interface with all these compute resources behind it, right, on this node. And so what I do here is I start up my Jupyter lab session with the specific ports and this no browser flag. And you can see here, again, it's running in this sort of local host URL, right? So it's running locally on the node there. But at least for systems like Expanse, we actually allow you external access to any node that you are running a job on, right? So if you have a job running, you can SSH directly into that node, right? So that allows you to set up one of these SSH tunnels very simply on a system like Expanse. So you don't have to sort of do these multi-hop things you might have to do on other systems. You can log in directly. You can establish the tunnel directly between your laptop and the node that your job is running on, right? So that's what's sort of happening in these screenshots. And then all you do is then you paste that localhost URL into your local browser, and again you have your notebook, but it's now running remotely on the Expanse compute node. Right? So you can do this manual way if you want, but we have something better now. Is kind of the rest of this talk, right? So what we've put together is what's known as a reverse proxy service for you. So essentially what you'll do when you want to run your Jupyter notebook remotely on Expanse, you'll, again, just log in with SSH to the login nodes. We have this special client called Galileo, which I'll talk about, which you'll run. What that does is it'll launch your Jupyter notebook job on one of the compute nodes. And then what happens sort of behind the scenes is that Jupyter notebook server that is started up for you on one of those compute nodes connects to sort of one of these management nodes or just another server that's running this reverse proxy service, which we call satellite. And it connects on the internal network from the compute node to one of these to the management node running this satellite service over just plain text HTTP, because we trust this internal network a little bit more. In the future, this will probably be upgraded to HTTPS as well. But then what happens is you connect from the outside world through the internet over HTTPS to this satellite service management node, right? So this, where this service is running, you get a fully encrypted HTTPS connection to your notebook, right? So it's sort of a nice way to, as you'll see, a nice way to give you the full, the most secure way to run a notebook on an HPC system like Expanse. And hopefully you'll see, I think it'll be much more convenient than, say, running your own SSH tunnels manually, right? So I don't want to get into the details of the satellite reverse proxy service, but if you're interested in sort of understand some of this kind of cyber infrastructure, there's a whole process of the different actions that satellite takes to that we use behind the scenes to secure these this traffic for you, and how that's done. There's a few different steps that are basically commands that are allowed in this satellite API that the client, in this case Galileo, uses to secure that traffic and provide you these URLs that you'll see that are sort of unique, one time only for the job that you launch. So this is just kind of a nice schematic of what's going on behind the scenes on satellites. What you'll see when you interact with satellites on your end, most likely at some point, there is a status page that you'll see. So once you launch one of these jobs, paste the URL into your browser. You'll see, depending on how busy the queue is, whether or not resources are available. Your job might sit there for a while waiting for your job to start, right? And then once your job runs, there's this mapping between the URL and the proxying through the satellite service that'll happen. So in some cases, usually what you'll see is you'll just be waiting in the queue for your job to start. Once it starts running, the rest of this happens pretty fast. So you might not even see these other steps here, but this is the status page you'll see once you start using satellite and this Galileo client. Okay, so so what is Galileo? So Galileo is basically a simple bash script to help you interact with this satellite reverse proxy service and the Slurm scheduler to launch your Jupyter notebook servers and get this one-time sort of token authenticated HTTPS connection for your session, right? And the link is here. I'll pull this up here in a second, probably. And so this is available. It's installed centrally on Expanse, as I'll show you. I'll do some quick demos here in a minute or two. And it's available there. You don't need to download it, install it. You just need to sort of put the path to Galileo in your shell, and you can start running the Galileo command to start your notebook sessions. So if you've been working on SDSE systems for a while, this is actually our second generation sort of client script for this satellite reverse proxy service. So if you've been using Jupyter notebooks on, say, Comet in the past or some of our other systems, there was a first generation start Jupyter script, which still works or should still work. It's just a little bit more cumbersome to use. And so if you're still using that, you may want to consider moving over to Galileo. And that's sort of why this second generation script was designed, where we really had some other use cases, like you'll see that the Expanse user portal is integrated with Jupyter now, and actually on the back end is this Galileo script. And for the HPC user services group, me and my teammates here, it's much easier to help you debug issues when setting up your software environment, right? One of the main, I think, advantages of using Galileo is how you can define your software environments, right? Many people are using different ways to start their Jupyter notebooks, need different sort of environments and different software behind the scenes. And so this will help you manage all of the things that Satellite needs to secure your session, but also manage all of the configuration for the software environment that sort of is actually sort of automatically written for you into your batch job script, right? You don't have to write a batch job script in here. In this case, Galileo is doing it for you, right? Where in the previous version, the Start Jupyter, you actually had to sort of manually go in yourself and modify the environment every time for different users, right? So, okay. So, oh, I got a little cut off. Sorry about that. So there's really only 3 steps to getting started with Galileo on Expanse. Again, I mentioned you basically just put it in your path for your shell once you logged in, and you can run this on the login node. It's fine in most cases, I would say. So we've had a few issues, but and then you have then you have access to this Galileo script, and the only command that you'll need is basically this Galileo launch, and then you specify a bunch of different command line arguments, which are intended to model roughly what you'll put into any sort of Slurm batch job script as well, right? So you have your account that you need to specify, to charge the job to on your allocation. You have the partition you want to run in. How many CPUs do you want? How much memory do you want? In this case, the memory isn't always in gigabytes, just to keep in mind. I didn't make a note here. How long you want it to run. And then there's a bunch of options for defining your software environment for, defining how Jupyter, what the software environment Jupyter should run in, right? So one thing to note is, right, Galileo doesn't install Jupyter for you. It doesn't set up your software environment. You have to set up your own software environment, right? So this is only just to access the software environment where you've installed Jupyter, right? Galileo assumes you have Jupyter installed somewhere and you pre-configured your environments, and now you want to access it and start your session with this, secure path, essentially, right? And so in this case, this example here, we actually have Jupyter installed, by default in some cases in different ways, right? If you log into Expanse, we actually have some just generic vanilla complete Anaconda distributions, which come with Jupyter installed, right? So if you just want to run a plain vanilla Anaconda software stack for your work, which many people probably are completely fine with, then you can just add in this environment modules flag, point to the modules that need to be loaded to get to that Anaconda software stack, and that's it. So once you run that command, what'll happen is you'll get this unique URL, which is essentially not only the URL you paste in your browser, but it's effectively kind of like your password, right? You don't really want to share that. You just copy and paste it in your browser over your SSH connection to the login node, and then you should be good to go. Again, there's a lot of different options in the command line options for Galileo to launch your script and connect to the satellite service. And again, it's the ones you're probably most familiar with are going to be all the ones that request your compute resources, right? Those should be fairly straightforward. You can request GPUs too. It's sort of, anything that you can do in a batch job script, you should be able to do, or anything that you should need to be able to do in a batch job script in terms of requesting how much time you want from Expanse for GPU nodes or compute nodes, or shared versus, debug nodes even, everything should work in terms of that. The options that maybe get a little bit more complicated that you'll need to familiarize yourself with is really on the software environment side. I would say there's a bunch of different options depending on what you're doing to try to support the most common use cases for how we see people using Jupyter notebooks on systems like Expanse, right? And so that's kind of what I want to walk through next, and do a few demos which are available from the website. So maybe I'll pull that up now. or from the just my Galileo GitHub page. My talk. And there's really three main sets of options for defining your software environment. There is this environment modules flag. There is a --sif flag. If you're familiar with Singularity and you use Singularity, you can launch your notebooks with Singularity containers. And also most common is the next most common is using Conda environments. Excuse me 1 second. Get a sip of water here. So there's all these three, there's essentially these three main options for defining your software environments. And in general, I will say, you don't need to, they're all sort of mostly mutually exclusive, right? In some cases, you might mix environment modules with Conda environments. You'll never mix them usually with also Singularity containers. So in general, my recommendation is, try to keep them separate. So, I mean, this is a common thing we see just with people writing batch jobs in general, where they start mixing, software that was installed in the module environments with software they're trying to install in their Conda environments. And it's, while it can be done, it's not ideal, right? These are all sort of separately managed software environments, and different assumptions were made about how the software is installed and compiled. And so it's, in general, keep these kinds of things separate. If you're using software modules in the standard software stack you see on Expanse, just only use that. If you're using Singularity containers, only use that. If you're using a Conda environment that you've installed, just only use that. Don't use all three. Please don't use all three together. So that would be, that's a little confusing. So, okay. So this is kind of where I want to stop and run through a few demos, but maybe I'll stop and ask if there's any questions, Cindy, since I haven't been looking at the chat.
Yeah, there's one in the chat. Oh yeah, it's asked how you define the Jupyter server working directory with Galileo.
Sure. Okay, so let me just get out of my talk here for a second, and I can show you. So if you go to the Galileo GitHub page, I'll put that in the chat for now. Right. There is, let's see, there is a list of options, right? And so you should be able to see there's sort of three different sections of the command line options. So there's the scheduler options that sort of define your job when you're talking to Slurm. There's only two options for Jupyter specifically, right? So this first flag is Jupyter if you want to use a Jupyter lab versus a Jupyter notebook. That's the only reason it's there for. By default on all of our systems, you don't need that flag if you just want to use Jupyter lab. That's kind of their new interface, right? But if you want to specify a working directory, your notebook dir, there is a flag for that. So by default, it'll be your home directory. If you want to point it to, say, the Expanse Lester file system, that's the flag that you would include. Okay. All right. I think that looks like it's the only question. So the question, Adrian, what are the benefits of this approach compared to OOD? So I guess the question I would have is, are you referring to OOD on the Expanse user portal, or OOD in general? I know OOD has some sort of, yeah, I'm not as familiar with the OOD approach. I don't know if Scott is here, who is the developer of Satellite. So he's our security guy that we work with on that. So he has, I know he has a much better understanding of the trade-offs with how OOD does it and why he wanted to do something different. So it's a little out of my depth. I'm sorry, I can't explain. the details right now. Is Galileo available on Jetstream? No. So this is only on SDSC systems right now. So let me go ahead, since we only have about 20 minutes left, let me go ahead and get started. We'll try to come back to some of these other questions in a bit. I just want to show you again a few demos here. So let me pull up a terminal so you can try to follow along if you have access to Expanse. But so yeah, if you're going to get familiar with Galileo and using the satellite service, please just read through the README a bit. It'll walk you through some of these examples now. But the first step, we don't have a module yet on Expanse for Galileo, so you would just paste the path here at the top to give the quick start part of the guide to get started. And now you have access to the Galileo scripts or commands. Okay. And if you keep reading down here, this first example is specifically for Expanse, since it's our biggest system with the most users, right? So in this example here, we'll launch a Jupyter Lab session on a single CPU core with 2 gigabits of memory, Expanse's shared AMD compute nodes, using this sort of base anaconda distribution we have available on Expanse. So you can just take this. The only modification that you should have to make is to your user account, or your allocation account or project ID. This is ours for the user services group. And if you run it, what you'll see is a bunch of output. The outputs here just to confirm essentially what you've set on the command line, right? So Galileo launch, I used this allocation to charge the job to, pick the partition, the CPUs, the memory, time limit, and then define my software environment using this generic anaconda distribution we have available by default. But you'll see if you look here closely, there's a few other things that are here by default, namely, by default, the Jupyter interface that'll start is the lab. And here we also have this Scratch directory, which I'll mention a little bit later, right? So if you're familiar with Expanse, this is kind of, you have a local hard drive essentially on every node, so you have access to some local storage while your job exists. But at the end, what you'll get is what's explained here in the text below. Is you'll get this URL, which is both has a sort of one-time random token versus and then also a random sort of host name that you'll use. And once you have that URL, you just paste it in, and luckily my job's already started, so so it's been running for a minute, so it's, it'll take, if you see your job running it, sometimes it'll take a minute or two for the satellite service to connect, but you can see I didn't even have to wait on the status page in this case. Luckily the system, maybe with the holidays coming up, people aren't working as hard, and so maybe the system's a little bit more available right now. But, so if you are requesting something like a full GPU node with 4 GPUs, you'll probably be waiting for a while. So that's one problem. Obviously, we haven't solved. We only have so many GPUs, but if you, I mean, you can request any type of resource essentially on Expanse that you need, but how long you wait depends on how popular they are and what the system status is. So it's really that simple once you start working with Galileo. Now, that's a very simple example for the environment, right? It's sort of a pre-canned one that we have available. There are other ways to start your notebook session on Expanse. And so let me shut this down. So if I shut this down and stop the server, you'll see that, if you do it correctly, the job will shut down itself and you won't lose any compute time. If you just log out and let the notebook run, you'll be wasting your compute time. So Let me see if there's a question. Yeah, so I'll answer the the DAS dashboard. So if you're, this is something that we're working on, is support for other applications that also use web server based interfaces. And it really depends on how, in terms of, say, this DAS dashboard, if it's running within the notebook, it's secure. If it opens up a complete different URL, it's probably not, right? And so this is one of these complicating factors that we'll hopefully address in the future. For certain things, you know, there's also one of the most common examples is with TensorBoard. It's kind of another thing. So it's sort of something that we have to address in the future with this service. I will, yes, Esteban, if the question is, can you have several users accessing the same URL to collaborate on the same Jupyter notebook? I would say yes, that is possible. However, remember, this unique URL is effectively your password to the notebook. And so how you provide that URL to a collaborator should be done securely. In general, it's not, you know, this will give them access to your accounts on the Exceed resources. And so this is not ideal. You know, it's obviously people share data and make things readable and sometimes writable for colleagues from account to account. So this is kind of that gray area where you're providing access to someone else, you know, accessing your home directory and other files. And so if you're comfortable with that, that's fine, but I would be very careful in those cases, right? And it's the same thing when you change permissions on directories for colleagues and accessing your data, right? And how much permission you want to provide them. In this case, you'll be giving them a full permission to do anything with the files that are available. Okay, so let me return to some of these examples. So in addition to using environment variables, there's also, I mentioned Singularity containers. So if you're not familiar with Singularity, it's a container platform for HPC and scientific computing that is available, I think, on every Exceed system. So if you're not familiar with it, it's a nice tool to get familiar with. I think one of the most common things we have people using Singularity for is there's a Docker container that's out there that they want to use for their research. You can, with Singularity, you can pull those Docker containers down to Expanse and convert them to a Singularity container and run those containers on Expanse, right? So you can't run Docker containers natively on most HPC systems, right? It's sort of, it's just, there's, you know, a long history of security issues with how Docker does things. And so Singularity was invented to solve some of those problems and make still the features of containerization available to HPC users. But with Singularity, it's nice. You can actually convert a Docker container into Singularity and run it, you know, pretty much out of the box in most cases, right? And so hopefully this will, yeah, maybe this isn't the best container to have here. Anyway, in this case, I'm pulling down, if you go to the Jupyter project website, they actually have a bunch of pre-canned Docker containers that include Jupyter. So in this case, right, if you want to run a sort of you know, standard R environment, maybe this R notebook container is one for you that you can use for your research. And with Galileo, you can again just launch, instead of using environment modules to create your software environment, you can just run the notebook with the Singularity container, right? Or in that sort of containerized software environment that's, you know, defined within the container itself, right? Now in Expanse, this is one of these exceptions cases where if you saw when I downloaded this R notebook Docker container, I actually had to load a Singularity Pro module, right? And so in this case, I will actually combine both an environment module load, just because I need to load Singularity. And if you're familiar with Singularity here, you can see this example. I have this bind flag as well. It's not too important to explain right now, but for people who use Singularity will probably understand that I'm making sure that the container, I can see both the Expanse Lustre file system and the local scratch space from the container itself. Oh no, what happened? So, yes, I forgot I purged my, one thing that's, if you're new to Expanse, is Slurm is also a module now. So I didn't include that, or it's usually loaded by default. That's why it threw me an error there. Right, so let's see. Now you can see I got the satellite reverse proxy service page. So that's sort of, my job is probably not started yet. That's started and it'll wait. You'll see this dial over here spinning. It's just kind of counting down. I think it's like a 1-minute timer where essentially satellite is running like a cron job to check the status of your case and when it's going to be mapped. And you can see here with the notebook started up. In this case, right, it's running inside this container. You can see, so you can kind of see you have a Singularity environment here, and again, there was this standard Jupyter R notebook container, which is what it's running in. Okay. And we have only a few minutes left, so I will show you one Conda example, then we can wrap up with questions. So in preparation for this talk, I added a slightly, one more sort of way to start Conda environments, which I hope is going to be, would be helpful if it becomes a standard long-term, but this was actually suggested by one of our colleagues, Peter Rose here. And this is a Conda environment file. If you're not familiar with Conda environment files, this is just a way to write down explicitly what is installed in your Conda environment when you create it. And so I'm going to copy this notebook sharing. This environment.yaml file. Oh, I already have it. That's right. I already probably downloaded it. So I have this environment file that'll define my Conda environment, right? So you can, install this in your home directory if you want. If you're familiar with installing Conda environments on systems like Expanse in your home directory, it's kind of painful sometimes because you're installing it over a network file system, and it can take forever. And so if you're making a lot of changes to your environments constantly, it's not ideal, or it could be just a bit frustrating. And so you can still do that. And, if it's already pre-installed, basically all you have to do. So if you have installed, say, this environment in your home directory, and you have your Conda environment initialized and set up to have the sort of Conda magic initialization stuff in your bash RC that you'll usually see, then all you have to do is add to Galileo a Conda environment and the name of the environment that you want to start, right? So in this case, the environment's called notebook sharing. If it's pre-installed in your home directory and everything's set up correctly, that's all you have to provide to Galileo. It should start that notebook session in that environment that you wanted from your Conda distribution. Now, the new way, the new option you have is to essentially, instead of installing Conda in your home directory, you can now use Galileo to just dynamically create the environment on the fly. And this is going to be installed in your local scratch space. So while your job is running, right before you start Jupyter, the whole environment's installed within the, say, Expanse local scratch It's NVMe scratch disk that's available on the nodes. So I'll just run this example and then we'll end with a few more comments from me and questions from you. So the reason for doing this is, especially if you, I mean, the one thing I really like about using conda environment files, right, is you can you explicitly write down what you installed, right? And so that really helps people like me in the user services group. When you have trouble with your conda installations, I can look at exactly what you tried to install and then try to understand and decipher what might be going wrong. When you install your conda environment, like sort of line by line, we have to sort of go back and try to remember what you sort out what you installed and what order and things like that, because if you've ever worked with Anaconda, it's like once you do one conda install and then another, maybe the one that came after uninstalled something from the previous one, and it can get kind of messy. So writing things down in conda environment files is I think a good practice to get into if you're using conda environments. And if you're going to use Jupyter notebooks on Expanse, you now have this option of just kind of keeping these environment files around, not having to deal with installing conda in your home directory and sort of all the pain that incurs and things. So the one thing about using this option is you'll see here I have to point explicitly to the absolute path of where the environment file is right now. But for me, it's just in my home directory. And so let's try this. And you'll see in this case, it'll take a little bit longer for the job to start just because it's going to install that conda environment, but maybe we'll go watch it happen. Oh no, give me priority. Let's just start another one just in case. That's not going to finish. So if you notice, we do have debug nodes on Expanse, both for compute and GPU nodes. So if you're just doing quick debugging and need faster access to some compute resources to sort of iterate, that's where you should go. The shared compute, GPU shared, that's really for production work when you just really want to use it as a batch system, like submit your workflow and let it go. Let's see if these are, oh, they're both running. Okay, let's just go to one. Of course, this is a new feature, so if it's not working, hopefully it's working. Okay, it's working, hopefully. So you see here, it's installing my environment. So there's a conda environment being installed here. And it's just using that environment file to do it locally on this scratch disk. So once the job is done, the environment's gone, but it doesn't take that long for most conda environments to get installed on these local fast hard drives, right? It's much more painful doing it on your in your home directory. If you want to do that, you can keep doing that. That's fine. This is just a new option that's available for you. Okay.
Artie, while you're waiting, there's a couple of questions.
Yeah, I will wrap up here just with the last two slides, I think, and then we can go to questions. So if you are using the Expanse user portal, behind the scenes, Galileo is helping launch Jupyter notebooks from there. So a bunch of if you get familiar with the options from the command line, you'll recognize when you look at the Expanse user portal, some of those same fields that you need to fill in. And so hopefully there is a user guide for the Expanse portal, which discusses these different options, but you can also use the documentation for Galileo itself, just because it's essentially using the same options and just passing it to Galileo for you, okay? And that's kind of it. I mean, one thing to keep in mind, right? Galileo and Satellite are still sort of prototypes under active development. And so we do expect things to change, and so should you. But we'll do our best to try to keep things working as is, so that the commands that you usually run are effectively the same. If there's a big change, we'll hope just shoot us an email and report issues, and we're still sorting out a few things for the future and what will be supported. But that's kind of it. So let's go to questions. Let's see. Oh, these are going to start here soon. Okay, so question. What's the first question? Let's see. Okay. Do you need Singularity Pro or Singularity? Well, Singularity, we have Singularity Pro on our systems, but it's not like a requirement at all. So if we do have other people using satellites and Galileo on some other HPC clusters that our teams don't run, and so they might just have the commercial or the community open source Singularity. We don't support Apptainer yet, which is the new version of Singularity, or one of them. But yeah, it's Singularity agnostic, as long as it's Singularity, exec and some commands that, command line options. It's what it supports essentially. Brian, yeah, on TSCC. On TSCC, no, Brian, you do not need to specify the memory parameter. If you look at the documentation, I think on all the TSCC examples, there's no memory parameter, and that's simply because TSCC, I think, always or only allows proportional memory allocation. So depending on how many CPUs you utilize, you'll get whatever the default is for that type of node. Next, Bruno asks, will the environment need to be installed every time I start the Jupyter service with Galileo? It's in this last option here, right, that I showed you, where I have this environment that's installed on the Scratch disk. Yes, that's installed each time. However, if that's only for this sort of one conda option. If you're using environment YAML file that you don't care to keep around in your home directory, that will be installed every time. But if you install, say, a conda environment in your home directory, it's always there. If you just download a Singularity container, it's always there, ready to go. If we're just using, say, the standard Anaconda distribution that we have on Expanse in the module environments, it's always there. So it really depends what you're doing. So it's really only for that this last conda example that I showed you. Okay, let me shut these down here. And are there any other questions for today's session? If not, and you haven't started using Galileo and the satellite reverse proxy service for your notebook sessions on Expanse, please, have a look at the documentation, give it a try. And if you need any help getting going, again, just, shoot us a ticket either through the Exceed user portal or just help@exceed.org, and we can, help you get your notebook session running with Galileo and satellites with however you set up your software environments on the system. So hopefully. But yeah, in the future, I think, someone asked about these other applications. That's sort of something that we're working on. Things like TensorBoard and Spark and other things that use web-based services will hopefully be integrated into this system eventually. It's just a matter of, effort and time. But Jupyter is kind of the first use case.